Allora, facciamo le presentazioni a pezzi. L'ingegnere Paolo Morini, 2/3 di voi già lo conoscono. L'altro terzo, cioè la classe terza B, lo conoscerà l'anno prossimo. Paolo Morini è il tutor esterno della formazione scuola-lavoro che farete l'anno prossimo, quella che già stanno facendo i ragazzi di quarta. Ovviamente il tutor interno sono io. Paolo Morini è brutto dire vice, diciamo che, come si può dire, è un alto dirigente, non ti dico che è vicepresidente dell'associazione Ravenna Astronomi di Reita, quella che gestisce il planetario di Ravenna. E sarà lui adesso a farvi la seconda presentazione. A te presentare il nostro ospite.
Ok?
Vicinissimo.
Ok, good. Prova. Ok. Okay, and today the language of the lesson is English, of course. We have an American teacher as a guest, and I introduce you Maureen Hintz, that has been teaching astronomy and physics for 26 years at the university, and she's also specialized in helping students who don't like science to learn science. And she also uses the planetarium in many of the classes, and she was recently awarded the Faculty Senate Award of Excellence for teaching in the College of Science. And Maureen is here because he has won a contest in the USA. The contest name is 2 Weeks in Italy, and a planetarian from the United States comes in Italy and visit in 2 weeks all the planetariums that want to host her. And since 5 years we take this chance, and so Maureen is here today for in the planetarium of Ravenna. There is a meeting of the Italian planetarians, and we got the chance to bring it to bring her here in this school, in your school. And that was also my school many years ago. And today's lesson is about the vocabulary words of the calendar and their astronomical origin. And for the fourth year students, we have to make the binocular classroom lesson for half of you. And we need only a clear night without the moon. And it seems very difficult to have with 2 days in advance for setting up an organization. From tomorrow, the weather will get worse, no sun, cloudy, so we wait for an appropriate day for our observation. Okay, thank you so much. Please, Maureen.
Well, thank you for letting me come. And, well, not that you had a choice, right? But thank you, teachers, for letting me come. And hopefully you understand English, because I understand 3 words of Italian. What do you think they are? Ciao. Wait, what? Ciao. Ciao, yes. Buongiorno, yes. Grazie. That's it. That's it. Pizza. But like you Italians, I like to talk with my hands. So that works really well. Yeah. Okay. So before we get into the calendar, I'm going to introduce myself a little bit. So I do come from the United States. Anybody been to the United States? Where did you go?
I went to New York and California and did a whole tour. I've also been to Utah.
Okay, yeah. Well, you went both sides. Yes. Sweet. Awesome.
New York.
New York?
Chicago.
Yeah, I mean, you're going to have to go across the ocean. Like, California is way on the other side. Awesome. Okay, so in case you have never heard of Utah it's in what we call the Mountain West, which means we have mountains, right? And so that building on the picture on the left, on the bottom, is my building where I go work at. Super ugly, I get it. It is. We do think it's ugly. But the mountains behind them are very, very pretty. They're very tall, covered with snow. There's some clouds, kind of make them look like volcanoes almost. It's kind of fun. Anyways, and then that's my family. I have 2 sons, and this is the marriage of my daughter. So then that's her husband, and then me in the blue. And then that's my husband. And I think as I was looking at this picture, this was a couple years ago, and I think that was the last time my sons wore ties. I think that was, and they haven't worn them for a long time. But anyway, so that's my family. Utah, let's see. I teach astronomy in my planetarium. That's actually my classroom. So every day that we have class for astronomy, we are in a planetarium. I hope you've all been to the planetarium. Good, because of Paolo over there. That's me in the planetarium projecting nebula all over the sky so we could get a cool picture. Anyway, so it's not a big planetarium. It only seats 45 people, but I have a lot of fun in it. Okay. All right, Utah is besides the mountains, we actually have. Oh, you have in there? Which one? Like the one over just.
On the left corner.
Yeah.
Sorry, the right corner.
The right corner. Yeah, that's very obvious. Yeah. Okay, so Utah has a lot of beautiful landscape geology. So we have a lot of beautiful geology. So on the top. I'm used to having a smaller screen. So this is me hiking in the mountains. I love to hike in the mountains. We have the largest concentration of what they call natural arches. So you know your arch, right, like this. But this is actually made out of rock. And so the erosion has cleared out underneath, and it's an arch. And that's me standing on it right there. This is a big one. Some of them are smaller, some of them are way up high. So we have an actual national park called Arches. Because it is, it's got about over 2,000 arches of different sizes, so that's kind of cool. In the upper right-hand corner, this is called Bryce Canyon, but this is kind of the opposite. Rather than being arches, these are mountain, like towers. They're towers of rock that have been eroded around. The word for the tower is called a hoodoo. They're called hoodoos, but anyway, so hopefully you can kind of see each of these is a tower that has been eroded, and you can see the colors really well. We also are known for our snow. The advertising people for the state of Utah called it the greatest snow on earth. So if you ski, it's supposed to be really, really good. I don't ski. This is me sledding. So I hiked up the mountain, and then I sled it down. Not fast. We also have a big lake, and it's a saltwater lake. And so when they came and discovered that it was a saltwater lake and that it was big, they named it the Great Salt Lake. Yeah, anyway. And so this is the salt. This is the salt in it. And the city next to the Great Salt Lake, they call Salt Lake City. Not the Great Salt Lake. Anyway, okay. And that's the big city. That's the big city. That's our capital of the state. And then in the upper middle, we see, hopefully you can see that in the image, Utah has had the continuous population, if you will. So it was settled by the people that kind of continued and built it in the 1850s. So now 1847 is when the first ones came. But it has been lived in by populations for a long, long time as they kind of came and went. It is a desert, so the water supply is unreliable. And so we have technology that could do it. So the water would kind of come and go, so the animals would come and go, so the people would come and go. But we know that they were there because they did graffiti. But the archaeological word is petroglyph, where they they communicated with this language, and we have no idea what it means. So we're left going, what did they mean? I mean, there's some kind of an animal. I have a point. So some kind of animal there, right? And then there's 3 people. Those are definitely people, but what are they? Are they 3 people? Are they 3 persons, or are they 3 groups of people? Or are they 3 families? We don't know. One person standing like this, one like this, and what does that mean, right? Or did they just have fun drawing? I don't know. And then there may be a moon. That might be a moon. Sometimes this, we tried, the archaeologists tried, but anyway, moon, maybe the sun, maybe something else. Anyway, and then there's these, we don't know. We don't know. But we're going to see another petroglyph a little bit later that is very important. Okay. All right. So that's it for me and introducing Utah. Today, the presentation, though, today is about the calendar and the vocabulary of the calendar and how it has connections to the sky, to events or things in the sky, and then also where some of it comes historically. We'll just kind of touch on that a little bit. But in the calendar, we have to look for things, and I want you to keep this in mind as we talk. We have to look for things that repeat, right? Because the calendar repeats itself. So especially in the heavens, we're going to be looking for things that do it over again, do it again, that repeat. Now, we're going to talk about 4 vocabulary words of the calendar. What do you think they are? They're not hard. They're probably one of the first words you learned in English. Month, year, day, and week. Very good. Use that. We're going to do that season a little bit later. But yeah, so the vocabulary of a calendar, right? Day, week, month, and year. And so we're going to look for things in the heavens that go with those 4 vocabulary words. Okay. And remember, we're doing historically, so we have to be able to go, what did they see with their eyes a long time ago? Okay. So the first one is the day. Now, how would you describe the day? And then we have a big group, so if you can raise your hand, that would be awesome. Or whatever. This is not a hard question. Well, maybe it is. Thank you.
The time that it takes the Earth to make
The time it takes the Earth to do this. Perfect. Rotation. Yes. Oh, and you gave us the second one. You said the time it takes to do this. And then she said 24 hours. Anybody else? How do we know? How does any know a day happens? How do you know a day happens? Perfect. The sun rises and the sun sets. I mean, these pictures all give you clues, right? All right. So those are great. So we have 24 hours. We have Earth rotation, and then we have the sun rising and setting. Well, I'm going to introduce a couple more vocabulary words. In my other classes, we discovered you have the same word in Italian. Just throw like a or a on the end of it, or say it with an Italian accent. Okay. All right. So let's do the sun that you guys talked about. So where the sky meets the ground, okay, where the sky meets the ground is called the horizon. Okay, so that would be, so here was our person. So this would be the horizon, kind of brown, ovally looking thing there. The sun rises on the eastern horizon. The word that we use for the sun appearing and coming up is rise. Okay, and then it goes up and increases, and then it starts to go down, and it sets on the western horizon. That should be reviewed. Okay, that should all be reviewed. Though but as it comes up, it kind of reaches the middle, right? The middle of the sky. And the word that we use to describe a line that goes from north through straight overhead to the south is called the meridian. Okay, and that's the same word that's in Italian. That's the same word in Italian. And so meridian, and so when the sun rises in the east, when it gets to that meridian line, that's the highest it's in the sky. And then it starts to go down. Right? And then it goes down. So then it sets in the west. And that, we'll talk about these a little bit later. Now, by definition, when the sun hits that point on the meridian, that is called astronomical noon. Okay, for you it's the middle of the day, right? Something like that, middle of the day. But it's called, that's by definition noon, and forever, when people started caring about what time it was, that's how they figured out it was noon. And every clock in every city, that somebody was in charge of watching the sun, and when it hit that, they would fix their clocks and they would say it was noon. Okay? So that is astronomical noon. All right. Oops, over here. Awesome. Okay, so that is our day. We're going to keep looking at the day. We had a couple other explanations. We said it was the Earth rotating, and that's what causes, right, the sun to appear for us that it's going up and down. I have a little YouTube video taken by the European Space Observatory. Space Observatory. Anyway, this is the stars. These are called star trails. And which side is east, left or right? Good. Why do you know that? Because it's where they're starting. Good, because the stars are coming from the east, going to the west. And then you visualize what the meridian is? Can you kind of see? The stars do the same thing. They rise, get that highest point, and then they go down. So they kind of got that somewhere there in the middle. Oh, it's over. Never mind. Okay. No, it'll come back. There we go. Somewhere like right around, when it kind of goes off like that, right? So they've tilted their camera a little bit at an angle. This is actually taken in the southern hemisphere. So that's it. That's the southern hemisphere down in Chile. Okay. If you want to YouTube, let's see. Nope, we don't want to watch it again. Okay. We said that the day is broken up into 24 hours. Does anybody actually know where the number 24? Why 24 hours? I'll give you a clue. I don't know if this will help, but the 24 hours comes to us from the Egyptians. Ancient Egyptians, so people that built the pyramids kind of stuff. 24 hours. Okay, I'll try another clue. They divided it into two sets of 12. 12 nights, or 12 hours in the night, and 12 hours of daylight. But still, why would they pick 12? It's because they had 12 fingers. No, they did not. No. So, why not pick 10 when you have 10 fingers, right? Why did they pick 12? Okay. I don't know if I have a guess. But I'm not going to tell it to you now. Okay? I'm going to wait till a little bit later. So you need to keep that number 12 kind of in your head somewhere. Okay? So then we'll pull it back and we'll go, oh, where's the 12? Okay. And then if you look at our clocks, did you ever wonder why we don't use 24-hour clocks? Why do we use 12 and then 12 again?
That's the shadow. The shadow is what does the clock. So at night you can't make the shadow.
Yeah, but why didn't we when we started making clocks? You're right. You were absolutely right. By the way,
But
everything you said is
we repeat like It repeats
It
itself.
repeats, yes, this repeating thing, right? But when we actually could make clocks like this, we already had our 24-hour day. Why did we stay with 12? Some clocks are 24, military clocks. But we'll come back, maybe we'll come back to that. We gotta have that number 12. Okay, those are just some fun sundials. Okay, how many minutes in an hour? 60. How many seconds in a minute? 60. Do you know who gave us those? Babylonians. That's the Babylonians. They also gave us 360 degrees in a circle. Because they had 60 fingers and toes. They loved the number 60. We're gonna maybe, but why? Why fall in love with 60? Now, 60 is divisible by a lot of numbers. Do you know that word divisible? So like I can divide 60 into 2 30s. I can divide 60 into 6 tens or 10 sixes. or 520 or 512 or 320s, 4 15s. So it's divisible by a lot of numbers. And that's what the mathematicians say is why they did it. But I have a different guess. A little bit later. Okay. All right. So that's the day. Any questions about the day? Or any additional comments about the... Oh, no, we're not done. Sorry. Just kidding. We're not done. Okay, we're going to actually look. I have a link here to a web program. We're going to go to this one, though. This is Stellarium. Have you seen Stellarium? This is just a web page. This is a web page. It's free. I'm not logged in. There's no advertisement. It's really nice. Okay. And you have control of some things, not a lot. Okay, I have to put my microphone down. You can move this guy around, but we're going to face south. You can put on a grid. Let's see, is that centered? Is that centered? Is that good? Is that okay? All right, what's this line right there? Very good, the meridian. Okay, also can control time. I'm going to stop it. Okay. All right, and then you can see there's a calendar over there, April 11th. And then you can see it's 1:30 in the middle of the night. And I can advance time. Boom, boom. East is to our left. West is to our right. Because we're looking up, not looking down at a map. We're looking up at the sky, and they're backward. And we can watch how the sky goes across, stars rise and set. Oh, now the sun's up. Can you find the sun? Oh, there it is. I'm going to put the sun on the meridian. Let's see. Oh, wait, I got to go faster. Okay, is that the meridian line?
Yes.
Okay, there we go. Is that center? Pretty close. Okay, so there, how did we define the sun on the meridian? Noon, right? Astronomical noon. So let's look at the time. Oh no. What time is that? 1:26, right? That is not 12. Any guesses onto why the clock would read different than noon? There's 2 reasons. What? No, the 13. It's 1 hour ahead. It's an hour and a half ahead, but it's a more than 1 hour ahead. Recently, did you just move your clocks to 1 hour ahead? Irritatingly, yes, right? In America, we call it daylight savings time. I think you guys call it. What does that translate to? Did you translate it or did you just equal time?
Yes.
What do they call it?
Legal time.
Oh, legal time. I'm sorry, it's the accent. It's not it's all legal. Okay, anyway, time change. We'll call it time change. And then the 26th because it should be, right? It should be noon. But the 26 is because of time zones. Okay, a whole different area of the world all has the same clock time. But the meridian isn't going to be, they all have individual meridians because the meridian is unique to where you are on the earth. And so everybody is having the same noon, even though the sun may have not reached the meridian, or it may be, in this case, past the meridian. So you might go out and go, oh, the sun looks really high. Don't look at the sun, it's dangerous. Okay, the sun's really high, because you're not looking at it. And then you look at your watch and you're like, what? That's not noon. Time zones and legal time. You'll be a little closer. Okay, but what we're going to do, but that's not what we're doing. What we're going to do is we're going to watch, you said 24 hours in a day. Okay, let's try it. Let's see. Let's see if we can do 24 hours in a day. So I'm going to advance the sky. Remember the time, 13:26. Right, let's just go forward, 24 hours. Let's go put the sun back on the meridian. And let's see how long it takes. All right, so it's 13:26. Here we go. Oh, it's nighttime. There's the Milky Way. There's the moon. Did you see Mercury? Yeah, Mercury. Yes. Okay, here it comes, and we're on April 12th now on the calendar, and 13:26 and 24 hours. Yay, everything's right with the universe. Cool, okay. Now, you may know the answer to this, you fourth year guys. The third year is in back?
Yeah.
The front, okay. Whatever. The fourth year, thank you. If you know, because you've been taught the answer to this next question. But anyway, okay, we're going to do the same thing with a star. We're going to see how long it takes the star to go around. But before we do, okay, so we need some stars. We got to set the sun. Let's get to nighttime. Let's pick, okay, we're going to pick this bright one down here that doesn't have a label. Spica. Okay. Okay. First, but we're going to make it easy on us, so we're going to put, oh, look at that. Pretty close. Is that good enough? That's pretty good. Maybe a few more. I think even if I do a minute, I think it would be too much. Oh, let's do a minute. Oh, that's too much. Okay, is that good? All right, so Spica is on the meridian. Now, I'm going to do the same thing. We're going to measure how long it takes for it to get back. But before we do that, you have to make a prediction. Do you think it's going to be 24 hours?
Yes.
Or do you think it's going to be less than 24 hours? Or do you think it's going to be more? It's easy choices, and you only have 3, right? 24 hours, less than 24 hours, or more. And the way you don't talk to your friends. No, this is not a talk to your friends question. The way you're going to tell me and your teacher is you're going to do it with a little finger. Okay, so you're going to do less than 24 hours is going to be 1, 24 hours is going to be 2, more than 24 hours is going to be 3. If you think, whichever answer you think it is, you show me the number of fingers. Okay? So I'm going to give you a countdown. So decide. This is a safe place to be wrong. This is also a very safe place to be right. Okay. All right, ready? 3, 2, get your fingers ready. 3, 2, 1. Show me your fingers. You guys sit back. I need to see them higher. Okay. All right, okay. I see 1 and I see 2. Did anybody have a 3? I didn't actually consciously see a 3. Okay, 1 and 2. I thought pretty even. Okay, here we go. Okay, guys, keep track. What's the time? 1:27. Keep track of that time. Okay. Here we go. Oh, here's daytime. What was the number again? 1. Okay, 1:27. All right, here it comes. Okay, here we go. Stop me when we get to the meridian. Oh, I went too far. Okay, what do we see? Big turn to the left. We just broke the universe, right? Or at least the solar system. Or did we, right? So we defined the day as the time it takes the sun to go around, the sun to go. We said the day is the sun going around. And we found that was 24 hours. We did the same thing with a star. Now, what's different between the sun and a star? Location, right? It's all about location. So the sun is much closer, and the stars are very, very far away. So there's got to be something. Now, the star took 23 hours and 56 minutes. So that was 4 minutes left. The question we have to ask ourselves is, what's going on, or why, or do we actually have 2 days? So let's go back to the pictures, slides. Oops, there we go. Okay, so we actually are going to define 2 different days. 2 different days. The sun is the solar day. No surprise. That is, when we think of our calendar and our day, that is the solar day. That's our 24 hours, that's our clocks, our watches, our clocks, right? That is it. But what is and that is because the earth is spinning. That the sun rises and sets. But what is the earth also doing? It is doing 2 things. It is spinning and it is orbiting the sun. Okay? And so here is spot 1. We're going to start at spot 1, of course. The little red little red arrow is where we are on the earth. Okay? And this line is pointed straight at the sun, so that would put the sun on the meridian, so that would be noon, right? Now, the earth is going to spin, and it's going to move. And so it goes from spot 1 to spot 2. Now, the red arrow is pointing, and the line is pointing in the exact same direction. So that means the earth from spot 1 to 2 has done 1 full rotation. The 360 degrees. But is it pointing at the sun again? No. So that, from 1 to 2, is our sidereal day, which is the day with respect to the sun. I'm sorry, the star. But we need to go to spot 3. The earth has to rotate just a little bit more so that the sun is back in the same place in our sky, because we live by the sun, right? And how long do you think it takes to go from 2 to 3? That was our 4 minutes. That's just, this is very exaggerated. This is very, very extreme. So there's our 4 minutes. 4 minutes more, and just a little bit more rotation. So that is so now we actually have 2 days. We have our solar day, which is our regular day, and then we have the sidereal day, which is actually the Earth rotation. So there was one time my husband and I were watching a game show. It's called Jeopardy, and it's known for being really, really hard questions. Hard questions. Okay. And so most of the time we get them wrong. And there was a question. One of the questions one time was, how long does it take the Earth to rotate? Well, my husband and I are both astronomy teachers. We look at each other and we go, 23 hours and 56 minutes. But guess what the answer on the show was? 24 hours. We wanted to write them and say no. Very few people on this planet know that the Earth actually rotates in 23 hours and 56 minutes. You are now part of that elite group, but you'd still get it wrong on the Jeopardy show. So if it was a writing one, you put 23 hours and 56, I would actually have complained. Of course I would have. Okay, anyway, any questions? That's our day. Any questions on the day? But that's also our repeating. Remember, we needed a repeating with and the stars just keep repeating. Okay. Next up is the week. Okay, there is no repeating motion in the sky that just kind of repeats itself on 7 days. Okay, so week is something very arbitrary done by mankind to give us a shorter time period. And the longer than a day, the shorter than our month. And like the Romans had 8-day weeks. The Mayans in South America had 21-day weeks. You know, so that's a lot of school days in a row. Right? Yeah, I hear ya. I'm a teacher. I hear ya. Anyway, but the 7-day, one of the origins of the 7-day is the Persians and the Babylonians began. And they are like, let's do 7 because there are 7 planets in the sky. Right? So there were 7 planets in the sky. So the planets in the sky, this is before Uranus and Neptune because you cannot see those with your eye. Right? So there were 7 planets. Saturn, Jupiter, Mars, Sun, Venus, Mercury, and the Moon. Those are the 7 planets in the sky, right? No? What's wrong? What's wrong? Okay, so she's telling me that the Moon and the Sun are not planets. And you are absolutely correct. Today, they are not planets. Right? What is the Sun? Star. What is the Moon? A moon, or natural satellite. Very good. Better vocabulary on you guys. Good job. Okay, but let's go back. And the Earth is actually a planet, but thousands of years ago when they did this, the Earth was not a planet, it was the Earth. Right? It was just it was its own special thing. And the planet, for them, were the dots in the sky. 2 of them happened to be bigger dots, or points, right, up in the sky. And the name planet in ancient Greece actually meant one. So there are a whole lot of dots in the sky. A whole lot of dots, right? Most of them are just, we call them fixed stars. So they are stars. I mean, they move. We talked about that, right? They move because the Earth is rotating. But in comparison to each other, they don't change. And so they're called the fixed stars, but there were 7 that would move over time. And it was those 7. So the sun, even though the sun today we know is not what we define as a planet, at that time it was defined as a planet. So this is a great example of having to be careful when we look into historical records, because as we in science learn more information, we have to fix our vocabulary. We have to fix the words that we use to describe things. We either have to change them completely, or in this case, we define the words we've been using, and then other things get thrown out. So it wasn't just Pluto that got demoted, the sun got demoted. Oh, the sun's not demoted, right? Okay, so those are the 7 planets that were visible, and they used those for the names of the week, the days of the week. We've got Saturn to Saturday, Sun to Sunday, Moon to Monday. The other ones look funny because in English they replaced the original god, the Roman god, with an English god of the same type, if you will. But in Italian it works really well, right? Because like Jupiter, which is Thursday, what's Thursday in Italian? Yeah, Jupiter, right? And then Mars, Tuesday? Yeah, so, and then Wednesday? I'll show you the name of the English gods a little bit later. So Italian and French and Spanish, you kept most of the words, except for sun, you changed that one. Okay, and then now the planets, the picture that I have is listing the planets in order of speed as seen from the Earth. Okay, so which do you think goes the fastest? Moon or Saturn? Which one do you think moves the fastest? comparison, but it still does. So moon is the fastest. Now, so they decided, okay, we're going to do the days of the week in order of the speed of the planets. So we're going to do Saturday, Jupiter, Saturn, Jupiter, Mars, right? That's the order of the week? Not even close, right? I'm going to show you the order, how they did it. They did use this, but they made it a little, they picked a kind of crazy way to do it. So I need a volunteer to write on the board. Somebody from the front row, would you do it? I don't know. It's really easy. Yay. Mateo? Okay, pick a color. Okay. They're all saying they're so glad to be here. That's so mean. No, okay. All right. Okay. Now, Mateo. This is Mateo. You guys don't know Mateo. So this is Mateo. He's awesome. You need to know him, right? Okay. He sits with all the girls. That's what you need. Okay. All right. Okay. We have on the board 1, 2, 3, 4, 5, 6, 7 for the 7 days of the week. And I have written 1 to 24. Where have we seen the number 24? Hours of the day. So yeah, so what happens is we're going to assign, Mateo's going to write down just the first letter of each of the planets as we tell you. We're going to just read them. You're going to write, we're going to start with Saturn, the slowest, so you just write S. Then we're going to go to Jupiter. Just write it. Okay. Sounds good? Yeah, awesome. Okay. All right, so what we're going to do is we're going to go in order of increasing speed. We're going to assign a planet to each each hour of the day, and then you'll just have to repeat until you get to 24. And then you come down to day 2. Okay? All right, so the rest of us have to help him, so he doesn't have to keep looking at the board. We're going to read the planets, right? So I'm going to point with my handy pointer. How do we not have a meter stick? That's okay. All right, ready? Okay, so Mateo, write Saturn, Jupiter, Mars, Sun, Venus, Mercury, Moon. Oh, was I going too fast? Oh, wait, okay.
And if you need to go this, sorry, of the planet, not of the planet.
That's okay.
Sorry, I mean,
Okay.
so Saturn, J.
Wow, he is so smart. He can write the planet. I mean, the days of the week. I'm not.
Mars,
Mars, Sun. Okay, all right, we're caught up. Okay, where are we at? Sun? Okay, Venus, so V, very good. Mercury, Moon. Okay, now we go back. Now everybody help me say these.
Saturn, Jupiter, Mars, Sun, Venus, Mercury.
How's he doing? You keep him on task. Okay. Okay. Oh, still going.
Venus, Mercury.
Okay, are we at the end? Okay, so now we go back. Now we go to day 2. Day 2. Ready? Mateo, can you go faster? Don't look. Just right. Don't look up here. Just right. Ready? Okay, we're gonna go a little faster, not tons faster. You guys yell stop if we need to stop. Okay, ready? All right, so we're on side because okay. Oh, wait. Too much giggling. Venus.
Saturn, Jupiter, Mars, Sun, Venus, Mercury. Saturn, Jupiter, Mars, Sun, Venus, Mercury. Saturn, Jupiter, Mars, Sun, Venus, Mercury.
Okay, how are we doing? Are we finished yet? No? Okay. Oh, where are we at?
Just one.
Just one? Oh, wait, where did we stop? Jupiter, your last one should be Mercury?
Moon.
No. I know what the answer is. Oh, I think you overlap. Oh, okay, yep. Moon, okay, and then let's keep going. So we were at Moon, and then Saturn. We only have 5 more days, guys. Let's do this. Saturn, Jupiter. No, we're not going to do all 5 days. Okay, we'll stop there. Let's give Mateo a round of applause. Okay, all right. So now we're going to give the name of the day of the week to the planet in our 1. Okay, so let's look at Mateo's list. We got Saturn for Saturday. We got Sun for Sunday. We got Moon for Monday. Is that sounding right? And then if we keep going, here's a picture so Mateo doesn't have to write them all out. Then we get to Mars for Tuesday, Mercury for Wednesday, Jupiter for Thursday, and Venus. I'm like, what's the last one? Venus for Friday, and then we repeat. That is where it comes from. Somebody had way too much time on their hands. And that pun was absolutely intended. You didn't get it. Okay. All right. So that's the order of the planets of the week, and why they are in the order that they are in. Because otherwise, you're like, well, how did they get this order? It's like this complicated thing. I encourage you today, when you go home to your family, to show them that. Right? That order of the planets. Okay. See if you can remember how to do it. Okay. Here we see the planets in order of the days of the week with their English, Spanish, Latin, and Old Norse or English word. So for Tuesday, which is Mars, okay, the god of war, Mars is the god of war, Tus is the god of war. So they just replaced it with their deity. Same with Thursday, which you probably know this god, though. This is Jupiter's the god of thunder, or his lightning bolt. Thor was the god of thunder. So it's Thor's day. Thank goodness we don't call it that. Anyway, okay. That's the week. Any questions on the week or comments? Okay. Next up is the month. Okay, the month is how many days in a month? 30, 31, 28. Occasionally, very rare, but occasionally, well, not very rare, but every 4 years, right, it's 29. Okay, but historically, by a long time ago, again, Egyptian, even the Chinese did this, the Hebrew, the Middle Eastern, they all used the moon to define the month. It is a repeating pattern, right? It is a repeating pattern for this kind of length of time. And it's the phases of the moon. So I'm going to assume you guys are good with your phases of the moon. Okay, at least the 4th year, right? So you have the new, we see the moon because sun shines on it, and then that reflects to the earth, and it takes 29.53 days to go around all the phases and then start over. But that's a half a day. How do you count a half a day when you're an ancient Egyptian? You round up, right? So you just use 30. So they just basically use 30 days. The Chinese would use 30 days, except when they were very, very careful, and then you might get to 29. Okay? So there's that as well. Okay, so that's just the month. we're not going to go into the 3031. That's the Julian calendar that you can, we have to finish. Okay, so any questions, none? We're good? We can kind of move on? Okay. All right, so the last one we're going to address, and then we're going to kind of pull them together, is the year. What's our time, by the way?
It's about to read, but we have time until 11.
Oh, good, okay, because I'm not close.
I'm going because I don't have
Oh, okay, so these guys have until 11. Okay, all right.
10:50. Because there's
Okay, all right, let's get back together. Doesn't take them long to start chatting. Doesn't take them long to start chatting with your friends. I hope you're discussing the week. Okay, all right, the year. How do we define a year? Let's go to the back. The front's been really good. How do we define a year? You guys in the back.
12 months.
12 months. Excellent. Where else? How else? You're good. What else? How else do we define a year? How do we tell that the year has gone through a cycle? You said it earlier. 4 seasons. Very good. And then one more. How many days in a year? 365. Very good. Okay. Okay, so 4 seasons. We'll start with the first one the ancients would have been able to see very easily, which was the seasons. Okay? Wherever they lived, there was some type of weather cycle. Okay? And so that's kind of hard to pin down on an exact number of days. In America, we have, like here, before I tell you the American story, here, you might have a really long, cold winter. Was this winter kind of long and cold? Like you're like, when is spring going to come? It comes with that. Or summer is really long. I feel like when you talk summer, it's forever. We have a tradition. I don't know if you've heard this, but we have a tradition in America, in the United States. It's not a Canadian thing. It's a stupid American thing. That is called on February 2nd. We have a creature called the groundhog. And on February 2nd, I think it's the 2nd, it's Groundhog Day. And what happens, so a groundhog is a small rodent. It's a big rodent. It's like this big. He's pretty big. Big porcupine without all the prickles. Very, very, you would love to snuggle him because he's kind of a big pillow. Anyway, he lives in his den. He hibernates over winter. And then on February 2nd, he comes out of his den, not willingly, but he comes out of his den. And if he sees his shadow, he gets scared and runs back to his den. If he sees his shadow, it means 6 more weeks of winter. And if he does not see his shadow, then spring is going to come. And he is right about 40% of the time. Which means it's completely silly. Right? It means nothing. Okay. But the ancients discovered pretty quickly that if we did our months, there were 12 of those months in the seasons on average. We got 12 months. Do you remember, where did we see the number 12? The hours, right? In the hours of the day. So this is where I think the Egyptians took their 12, because they were very much into the sky. So if we're an ancient Egyptian, we have 12 months, we do 30 days per month, we get to 360 days. So, yeah. So she's up here saying they partied, right?
Yeah, they said they had this myth that the goddess of the sky needed to birth her children, so the god of time gifted those 5 extra days so that she could birth her children.
Okay, yeah, no, it's 365 days. The year is 365 days. But they didn't want to use, they wanted to use the year. Okay. Oh. Thank you. Thank you for fighting down. Okay, so so we know now it's 365 days. They wanted to use their months, and so they got to 360. Where do we see 360? In the circle. Yeah. So that could be the origin of the 360 by the Babylonians, because they also used 30 days in a month and 12 months in the year. But they knew, even the ancient Egyptians, they knew it was 365. So it's not the moon that's going to get us 365. There's got to be another observation that we can make that will get us 365 days. So we're going to go back to the sun. Okay, so this is our picture of the sun that we had in the book beginning. Now we're going to talk about those different lines. So you all should know, because you're in high school, that the Earth orbits around the sun at a tilt. And that tilt stays the same during the course of the year. I'm going to go this way. And because of the tilt, the angle of, and we live on a ball, we live on the ball, that the angle of the sun, as seen by a person on the Earth that stays in the same place all year, the height of the sun above the horizon changes. Okay? Sometimes the sun is not very high, okay, and it's pretty low, and you feel like you're always looking at it when you're driving. Sometimes it's very, very high. Now, this is an illustration for a person at about the latitude of where we are in the northern hemisphere. Now, remember, our calendar requires a cycle, something that repeats itself. The seasons repeat. How is the sun's height repeats itself? So instead, we're going to look on the horizon. So the sun rises on the summer solstice. The sun rises at a point that is the most north seen for this observer on the horizon, and it will set the most north of west on the horizon. And it's up, see that arc is very, very long, lots of sun patterns. That's our longest day of the year, daylight for the year. It's still 24-hour day, but it's the longest daylight. When the sun, now that's the only time, there is only one day of the year that the sun will rise right there. After that, it will rise here, then it will rise here, 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 until it rises straight east. When it rises straight east, it will set straight west, and it will be above the horizon for 12 hours, and it will be below the horizon for 12 hours. So there's and we call those days the equinox, and it does that in September. Then it will continue to rise further south until it reaches its furthest south point on the horizon. And then we call that the summer or the winter solstice. And then it will go back. And it will cross east again on our vernal equinox or spring equinox, and then it will come back there. And there is our cycle. You'll just go back and forth, as seen on the horizon, all year long for 365 days. People have been watching this for a very, very long time, and they built all of their structures with relationship to the sun. It feels like once the archaeologists realized that these structures were being built with the sun, they pull in the astronomers. You get archaeoastronomers, and they're like, oh my gosh, now we know why they built it the way they did. Stonehenge was built in line with the summer solstice. This building, this is a tomb in Ireland. It has that opening. The sun shines through that opening sun is low on the horizon, which is the winter solstice. That's the only day light shines through that opening on the top. For the longest time, they had no idea what that was doing. And then this is my hallway at UVU. My planetarium is right there. That's the door to my planetarium. On 2 days of the year, the sun will shine, well, a couple days. The sun in November and in January will shine, when it sets, will shine straight into the hallway. Otherwise, it just kind of does angles and stuff like that. 2 kind of in November before the solstice, and then in January after the solstice. Okay, I'm going to show you one of the coolest locations in the United States. Okay, so this is in Chaco Canyon, New Mexico. In Chaco Canyon, New Mexico, about 1,000 years ago, people lived, and they built this amazing city, and they decided, and they were avid sky watchers, okay? And they climbed to the top of that little butte. That's called a butte. It's kind of a very difficult to climb kind of little mountain in the middle of the canyon. And they arranged these 3 slats. These are big pieces of rock that are taller than me. So they're 2 meters, 2,000 kilos. So these aren't little. These are huge. And they arranged them in that little kind of pattern. So you have 2 openings. So you have an opening here on the left, and you have an opening here. Now behind it, on this rock, they carved out a petroglyph, a spiral. Okay, there's kind of an illustration. A spiral. Now, on 1 day of the year, the sun shines. Now, okay, let's get back to most of the time, the sun shines through, and you get 2 beams of light, and they're not special. They're just there. 1 day out of the year, just one, this is arranged so that when the sun rises and shines, nothing goes through there. Only light goes through there, and it makes 1 beam of light. And at the beginning, when the sun starts to shine, it does just a little beam of light, just a dot. And then the dot grows and grows and grows until you have the line. And that is called the sun dagger. You know what a dagger is? It's like a knife. Yeah. Okay. That is called the sun dagger. Now, only 1 day out of the year does this happen. That is on the summer solstice. And then you watch for 365 days, and you have 365 days before you get to the next, where the sun is just 1 beam instead of 2. And that is how you can get 365 days. You would count it. So this one is the winter solstice, where it brackets the spiral. It's a little hard to see the illustration. And then there's a second spiral that's over here. You can see it in illustrations, and that shows up, and that gets used on the equinoxes. This is an amazing site in the United States, and like I said, it dates about 1,000 years ago. We don't know exactly when. That's when people were living there. They haven't lived there for 600 years. They haven't lived there for 600 years. Okay, so that is the sun dagger. Now, I think we have time to do this. So, teachers, do you guys have writing utensils, like pens? Okay, we're going to hand down a little Post-it note. Okay, we're going to have to do this organized. You guys are a big group. So what I want you to do, can you just pass this down so everybody gets? Take one Post-it note, and please write on it your birthday. Okay, your day and your month, and write out your month in letters, like January. You do not need to put your year. No year. Just day. Okay, all right, I'm going to explain what you're going to do. Okay.
Ragazzi.
This room has fabulous reverberation. Okay, what we're going to do, so there is a picture up there. Okay, up there is a picture of Chaco Canyon. This is where the sun dagger is located. Okay, this is the east. They have a beautiful view of the eastern horizon. No wonder they could easily keep track of the sun. They had such a beautiful view. There are suns located at the spot. Now this is where the sun will rise on the summer solstice. Okay, so that's on about June 21st. It oscillates a little bit. And then this is where the sun rises on the equinoxes, March. On September, so rises in June, rises in September, rises in December, and then rises in March, rises in June, and then it will rise, between. So you have written your birthday, okay? So we're going to come up by row. We're going to start with the first row, and you're going to come, so you're going to lead. We're going to come this way. You're going to come this way, and I have the same picture on the table. You need to look at your birthday. So you guys in the back, figure out where you're going to put your birthday, because you're going to put your birthday on the location of where the sun rises on your birthday. Okay, so can you direct to the next row? Okay, you guys come this way, and then you're going to go around. Okay, so you guys come up. You guys come up. You're going to go this way. Perfect. Thank you. Okay.
My birthday is in January. My birthday is in January, right there.
You just put it. Sorry. Just come put your birthday. Next Okay, just kind of follow the line, and if you have to go down to the third, follow the line.
A ottobre, ma ragazzi,
Don't take too long, and then just go back. Just go this, and then go back. Hey, go, guys, go around.
quindi lui va a sinistra. Giugno cos'è? Giugno?
Però ma il 27 febbraio non è mai... C'è una che aveva il 27 febbraio
mi sembra un po' sbagliato quello, o no?
non ho idea.
Non si può andare oltre il solstizio d'inverno.
Mary, dov'è luglio?
Dove fare?
Hurry.
Perché c'è
I'm not telling if you're right or wrong yet. You decide. Do not assume anybody is correct. Okay, then I am not telling them if they are right or wrong. Don't assume.
Come fa a febbraio?
Infatti non ci può essere febbraio.
Come fa ad essere febbraio?
Marzo, fine marzo, giugno, luglio.
Perché riesce ad essere? Perché qua marzo? Come può essere lei? Non può essere febbraio, ma raga, ma allora lo metto. No raga, lui è quasi gennaio.
No, perché fa? Marzo, maggio, giugno, poi torna indietro, fa luglio,
Okay, quickly.
dicembre, febbraio, marzo. No, è più da più là.
Go. All right, just put it down. Don't think about it. You've had time to look. Just put it down. Just put it down where you thought. You can put them up here if you want to put them up here.
Che secondo me...
Don't assume these are correct. They might not be correct.
Vabbè, esatto. Perché tu hai
Okay, keep going.
Vabbè, qui dovrebbe essere qui in mezzo.
Thank
Come cazzo fa?
you.
Vabbè, tutti l'hanno messo lì, lo metterò anche io qui.
Okay, awesome. All right. Summer, June, March, September, and then December. Right there. Okay, you can put them up here if you want. You can also overlap it.
No, vabbè, tipo 21 marzo, 29, però le forze.
Okay. All right.
Non lo so. Ma lui ha messo marzo.
Don't assume they're right. They might not be right. Because I'm not telling them. No, ragazzi, non so. This is December, this is June, September, and
Beh, qua.
Are you guys coming back?
Perché hanno messo tanto per farsi? Questo è gennaio. Qui c'è gennaio. Ma no, sì, no, è tipo la relativa al contrario in realtà. Cioè, tipo è marzo.
Okay, don't think about it. Just do it. These are not necessarily correct. Okay? So you put it where you think. So this is December. That one's December. Okay, is this our last row? This is our last row.
Infatti, però
Yes.
e tu è qui il coglione. Però io volevo spostarli. No, vero. Cioè, perché scusa tutti quanti, però vabbè, bro, cioè allora aspetta, marcia qua,
Quick.
sì, va bene.
All right, is that everybody? Okay. Don't worry, nobody can read your handwriting from this distance. So I'm going to have, I teachers to come hold. Can you come hold? Teacher. Okay, all right, so remember we said for the calendar we need things that repeat themselves, right? And so the sun, as seen on where it sets, this is rise, where it rises on the horizon, changes over the course of the year, right? And it repeats itself. So here is where it rises on the summer solstice. That's June. That's the farthest north it ever rises. The sun will never rise over here. Okay, so these are in the wrong place. It's okay. It's okay. Then, we're right here, somewhere in here, is the equinoxes, March and September. And then this is the winter solstice. That's as far south as the sun will rise. So it will never rise over here. Okay, all right, so we got some in the wrong place. Now let's look at where the sun is during, okay, so let's start with the winter solstice. Okay, so that's December. And so then in January, the sun's going to be over here. February, the sun's going to be in here. So we've got a bunch of February. Good job. Very, very good. Then, March, thank you. Where am I? March. Now, if you are, now, we have a March 9th right here. That's perfect because it's March 21st right here. So we're earlier in March 21st, around. Then April, so a whole bunch of Aprils, but there's also some September. That's okay, we'll get to it, right? So March, April, May, June, July, August, and we're back to September. So we do get the same one. So this one is 11th of June, right? That should be in here. 22nd of May, maybe a little further over, but not too much, right? And then we go to September, October, November. So our November and our January are in the same place. And that's what they should be, right? And then December, did I say November? November, December, and then we repeat. So there is our cycle that the sun does as seen on the horizon when it rises. And so let's fix, so we gotta fix these because they're gonna make us crazy. So 1st of February, probably kind of a little more over in the middle there. 26th of January, not as far as February. Oh, these are the same birthday. 26. This is December 28th. Where should that go? If this is the December, just a little bit, right? Just a little bit. 1st of January, beyond that. 29th of December, right before right after the 29th. 27th. On the other notes, there we go. And then the 22nd. Oh, right next to it. Okay. All right. Good job. I didn't pay attention to all the ones in here. But hopefully that was illustrative of this repeating pattern. Okay, thank you. All right, do we have time? Okay. All right, now we can do the same thing with the stars. Okay? It turns out, we saw earlier that the stars in a day will rise and set. We also saw that the stars, as the Earth orbits around the sun, we get different stars. And so if we look at the sky, this is looking east on April 5th. Okay, and if we look at this, look at the constellations, look at the stars, and then I'm going to move this sky forward 1 month. Same time of day. I have to do this for the same time of day. The stars are going to move. They move further west for the same time of day. Now I'm going to jump 2 months ahead. Make a prediction in your head. Just make it in your head. And then where are they going to be? Like Arcturus, Bootes, Vega. Where are they going to go? Arcturus is gone. It's gone above past the meridian. So everything's just a little further. So if we are smart enough, if we know what month or what, where we are in the year, we can also figure out what time it is during the night based on the star. And the Egyptians did this 3,000 years ago. They had a table of stars. They used 36 different stars to track the time of night. Because without the sun, how do you track? Well, you track it with the stars. But you need to know what time of year. So I have brought star clocks. But I don't have enough for everybody, so you're going to have to share. Can you hand down like 3 or 4 per row? Okay, so every 3 of you are going to share. Does that make sense? Or maybe every 2 of you can share. Okay, let me explain how you use it, or you can read the instructions. Okay, all right, so the way that you use the star clock is you have to know the month. Okay, how do you know the month? You look on your phone, right? You look on the calendar. Or you look at the sun and where the sun is on the right. So you have to know what month it is, right? And you put that at the top. Okay? So if it was February, I would put February at the top. And then I would have to look at the Big Dipper. The Big Dipper is the one on the right of the opening. Now the middle, you have to hold it so that the month always stays on top, and then the black part can spin. Okay? And what you're going to do is you're going to orient the. Let's see. Do we have the Big Dipper? I don't think so. No, we're not facing north enough. Okay. All right. So we're going to try to see if you can figure out the time of this screenshot. So I took a screenshot of Stellarium in the north. So there's the Big Dipper. Here, Paolo, you get to try. You can use mine. Okay. Here's the Big Dipper. Put May on the top. So May has to be at the top. May has to be at the top. So make sure that May at the top. Okay, I'm gonna play. What time did you get?
Around 7 a.m.
7? Around 7? Between 7 and 8? Okay. Anybody get a different time between 7 and 8? 4 Okay, this is actually, oops, I hit the wrong button. 8:30. It's a subtle, it takes a subtle art. Okay, give it to the other person. To the other person, we're going to do it again. One more time. Now it says September. This one's hard. Okay, thank you. Okay, this one is 3 o'clock. 3 a.m. Okay, all right. Okay, that is, so we actually pulled, to do this exercise, we pulled together the Earth's rotation, which is a day, related to a day. We had to pull together the Earth's orbit, which is a year, because the Earth is doing both of these at the same time. And so there's a lot of motion going on in the sky, and when you start to look up, you become very aware of that. You'll notice the moon in different places during the day. You'll know, and then watch the stars. You'll notice the stars in different places in different times of the year. And all of that has been used